we're going to talk real briefly about the derivatives of some trig functions and how you can use them. So in this very first example, we've got sine divided by cosine. I'm going to find the derivative of that, so f prime of x. Now because it's a quotient, it's sine divided by cosine, I've got to use quotient rule. So I'm going to do low, t high, derivative of sine is cosine, minus high, t low, derivative of cosine is negative sine, cross the line and square the low. Alright, well, cosine multiplied by cosine is cosine squared. Now, I want to talk notational here. A different way to write that is cosine squared of x, like that. Now, up here we got minus sine times negative sine, so it's negative sine squared. So minus a negative becomes plus sine squared of x all over cosine squared of x. And please just note that these two things, the cosine of x squared, the whole function squared, is the same as this. Well, from trigonometry, you know that cosine squared plus sine squared is equal to 1. So we have 1 divided by cosine squared, which of course 1 divided by cosine is secant. So 1 divided by cosine squared is secant squared. Well, going back up to the top, sine divided by cosine is tangent, right? So what we've just found is the derivative of tangent using quotient rule. So the derivative of tangent is secant squared. Okay. Well, you can look at this, of course, and say, well, cosine divided by sine, that's cotangent. And we could do the same exact type of thing here and use quotient rule again. And I'm not going to do that. Let me just tell you what we'd end up with, that the derivative of cotangent is negative cosecant squared. And it's a very similar proof. Okay. Now the others, the derivative of secant, the derivative of cosecant, you can rewrite secant as 1 over cosine and use quotient rule. You can rewrite cosecant as 1 over sine and use quotient rule. So they're all just quotient rule using sine and cosine. So here are the derivatives. I put them over here on the right that you need to memorize. That the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of secant is secant multiplied by tangent. Notice they're two functions multiplied together. It's not a composition. It's not the secant of tangent. It's a product. The derivative of cosecant is negative cosecant multiplied by cotangent. And the derivative of cotangent is negative cosecant squared. Okay. So to find the derivative of, and I'm sorry this got a little messed up in transition, it should be 6x squared plus 4x multiplied by secant. We're going to look at this as a product. So the derivative, we'll use product rule. So we'll have first multiplied by the derivative of the second. Derivative of secant is secant times tangent plus, then we do the second multiplied by the derivative of the first. Yeah. So that's our derivative. Now I had put up here that, if we wanted to evaluate it at 0, of course we'd just do f prime of 0, plug in 0 everywhere. Of course, 6 times 0 squared plus 4 times 0 is 0. So this whole thing is 0. And actually the tangent of 0 is 0 as well, so it's 0 times 0, which is 0, plus the 12 times 0 plus 4 is 4, and the secant of 0, well, think about this like it's 1 divided by the cosine of 0. Cosine of 0 is 1, so 1 divided by 1 multiplied by 4 is 4. So that's the slope. So we get to do some pretty tough functions. Next, cotangent. So the derivative of cotangent is negative cosecant squared. Again, this notation right here that I'm using is the same as the notation over here. They're the same thing. Okay, this is probably the preferable notation that I'm writing. Minus 14x. And if I want to evaluate that at pi, let me start with the easy part. It's going to be minus 14 pi. Well, negative cosecant squared is the same as negative 1 over sine squared of pi. Well, the sine of pi is 0. So I end up with negative 1 divided by 0 minus 14 pi. So I really have undefined minus 14 pi, which is undefined. So what that tells me, knowing what cotangent looks like, knowing that cotangent looks like that graphically, the fact that I couldn't find the slope means I must have been trying to evaluate it at one of these asymptotes.